So welcome and thank you for joining. The first thing that we're going to do is we're going to show how you can load data into LogScope using LAS and DLIS specifically. We're then going to show you how to do formation entry, and then we'll show you the petrophysical computation and how it's cross-block based. We'll show how zones are added. And then we'll walk through the plot manipulation, and then we'll go to some of the functions. Firstly, how you can create a T2 distribution from the raw echo trains, and then how you can smooth that. And we'll go through the reporting of the of the results as a hydrocarbon volume report, and show a little bit of the Excel output and the histograms that are generated, and then how you can produce a PDF. Basically, the plot that was produced in our NMR post. Here we go. So basically, we're going to walk through the loading and the interpretation of the data that was appearing in the LogScope article that we published a while back. On my screen, I have two files here, an NMR example.las file and an NMR DLIS file that contains the NMR data. In LogScope, you can load the data by simply double-clicking on the file, and we'll do that with the LAS file first. And it just opens LogScope and opens the data like so. So we have the tracks and the data loaded like so. LogScope has the menu items across the top. We'll talk about the log analysis, and we'll talk about the functions a little bit later. On the other side, we have view, which allows us to manipulate various view functions. There's a function called trim, which allows you to trim the various data sets, and then merge is the function that we're going to use to load the DLIS file. So you select the merge function and the well, and then you load the DLIS file like so, and it will just pull the DLIS file data in like so. So the DLIS file is now loaded into LogScope, and we can manipulate the tracks by simply dragging. We can drag curves around like so. We can move tracks like so. And we can click on it and move it back like so. We can save these as a template, and I have already built a template for the interpretation, which I'll load now, which is called the analysis NMR echo comparison. So I've loaded this data, and if we start from the left to the right, we have the gamma ray, the resistivity, and the neutron density information here. And then we have the NMR echo trains in this track and this track here. And then we have the T2 waveform spectrum, and we have the T2 as a VDL here. And then we've got the pore space bins that we haven't calculated yet, but will be calculated in a minute. And then we've got the spectral gamma ray, and then we have the computed petrophysical parameters here. I'll just open up the log analysis. LogScope allows you to do the processing as a bunch of functions. So I'll just work my way up and down the list. And you can do these functions individually, or you can do them all together. And as you can see, it's got an NMR function in there as well. LogScope recognizes a variety of LogScope parameters and curves, and it will actually pull in the curves that it sees and load them straight away. This one is using the default T2 distribution from this data set, but I want to actually use my T2 distribution, which is called T2 spec, which is added at the bottom here. And then the final parameter here is a list of the parameters. And these are all the parameters that are used in the petrophysical evaluation. I'm just quickly scrolling through them. There's a lot of them. I can actually see the petrophysics parameters by just typing in /p:/NMR, and that will give me a list of the NMR parameters. And this allows you to put in hydrocarbon density, the size of the array of the T2, and you can select all your different bin sizes, bin cutoffs, and the clay cutoff, the free water cutoff, a scale parameter, the permeability, and a gas correction parameter in there as well. So we'll manipulate those in a minute. Let me just move that out of the way. Time being, you can set up zones for each zone, and you can manipulate the NMR parameters for those zones independently. If I want to edit the zones, I just take the zones and edit, and I can put a new zone in like so, or I can manipulate an existing zone, which is what I'm going to do here, and I can edit its name, and I will call it NMR zone, and I can move that up or down as well, and change the colors as well. So we'll just put that back there, and we'll save it next it. And now we'll go back to the log analysis. And the first thing I want to do is load the parameters, and LogScope is a crossplot based interpretation methodology. To save time, if I've already got the parameters saved somewhere, I can actually load them in by just selecting on the parameters load, and it will go away and it will find the in the parameter store that I've created, the parameters associated with this, and the various parameters that are stored there. You can have multiple wells in a parameter store. In this case, we're going to get one well and one set of parameters, and we'll just load that in like so. And it's adjusted all these parameters here. So basically, all I have to do is just do process, and it will go through and process the interpretation like so. So here we have the pore space with both my phi t in red and the bins plotted on top of them, showing a really good match between the phi t and the pore space here. Now, I said LogScope is a crossplot based package, so I'll just go to the crossplots, and you can access those down here like so. So we go to the cross plots. First time you use LogScope, you're presented with a blank cross plot panel here, and you can set up your own cross plots, but we're not going to do that. We're going to go through the list of cross plots we've got here, and we're going to go to the log analysis, which is here. The cross plot allows you to have a side panel next to it, which is the list of all the parameters. And if we clear out the search bar, it shows the parameters per zone and per cross plot, all the parameters that are relevant to the cross plot. We're using a silty shaly sand model for this data set because it's clastic. You can move your points on the cross plots like so, and you can work through your cross plots. We've got the neutron density, sonic density, and so on, like so. We also have the ability to play with the hydrocarbon density, and that's shown here. In the silty shaly sand model, it automatically calculates the hydrocarbon density, and as you can see, the points are brought back here on the cross plot. There are other cross plots for doing various other different things in here, like the spectral gamma ray plots and so on, which allow you to use the spectral gamma ray for calculating the clay types as well. So the other final thing, if I go back to the neutron density cross plot, I can choose data like so, and I can do regression. I can save it as a zone or as a region or as bad hole. I can also plot the data as a side plot, and I can also use the region zone to manipulate and to look at data points there. Those sort of functionality was used when doing this interpretation. So if I go back to the plot, I can now work through the two functions that I wanted to talk about, which is how to produce the T2 distribution from the echo trains. That's under the function here, and it's the NMR function down here. So I click on that, and I can actually choose the NMR echoes. It will automatically choose them for you if it recognizes the echo mnemonics. You have the start time of these echo trains, and then you have the T2 distribution start and end, which is specified in milliseconds, or microseconds as they are here. So we can put in milliseconds like so. The width is 50. On this data set, there's a short echo length, which is 33. And then we've got a smoothing parameter called beta, which is part of the approach, which is taken from a penalty method developed by Borgia and co. And we change this to 5. Lower values will give a much more smoother look, and if we hit OK, it will now process that and it will produce a new T2 distribution. Yeah, the T2 distribution is produced using all the data. There's no, it does some internal smoothing, but if we want to smooth this out, LogScope gives us the ability to actually smooth that, and I can smooth that by using a basic Gaussian smoothing. So I can select my T2 distribution here. And for that, the presentation, I did a 2-meter window, and I smoothed and created the T2 distribution like so. So in LogScope, you have the ability to take the echoes. You can generate your own T2 distribution. We can play with the bins. And on top of that, we have our phi t, which is the red curve. And if we just tap on that track, you can sort of see the values of the phi t, phi e, and the total fluid volume, which is plotted there. And then we just go back to our log analysis, and if we go to the NMR, we can actually look at the NMR distribution here, and we can play with these here. The NMR scale parameter is set to 0.001 because the T2 distribution is tenths of a volume for volume. And if we just hit process, it will recompute our curves. And here you can see that we've got the bins recomputed, the permeability has been computed, and the V-clay has been updated with a little bit more character. And we can sort of look at our T2 porosity versus our phi t. A few other things that LogScope can do in terms of the logs that are loaded is that if we want to use the T2 distribution as a phi t, you can actually use that as an external phi t and an external, and we can also put in an external phi e. And we can also add in, other logs such as an external n and m values as well. But once these values are, once this is computed, if you want to produce a hydrocarbon volume report of the data with some histograms of the distribution of values, you can do that using the hydrocarbon volume report here. And you can output just basic parameters as a CSV. But if we change it to a spreadsheet, we can actually output actual spreadsheets. So if I load a template that I've already set up for this, I can set this up as a template. And I have 4 histograms that I've set up. I've got the porosity, permeability, saturation, and the pore throat, or the pore porosity from the that's computed from the NMR, and I can hit process, and we can save this. We save it as a spreadsheet. If I go into the spreadsheet, it shows us the porosity, permeability, saturation, and pore throat as a distribution. We have the summary of all our parameters. So that's the report part of it. And if we want to produce a CPI plot, we can just go to the export, and we can export the data as LAS, DLS, CSV, and so on. And we can load as, we can export as a PDF. We can choose our parameters here, and we can choose a presentation that can have all these included in the analysis parameters, which I've added in the model, the T2 start and end, and the clay cutoff parameter there. And I've already produced this, so I'll just open up this plot. And we have the presentation plot just here like so, with all the data and all our zone parameters. If we have multiple zones, they would be displayed here as well. So that's basically the how that presentation was produced.